Good day students, I am Rajesh Khanna, Assistant Professor of Physics, Nehru Institute of Technology, Coimbatore. This semester, Engineering Physics is the one of the paper. The Engineering Physics contains 5 units. Unit 1, Properties of Matter, and Unit 2, Waves and Fiber Optics, Unit 3, Thermal Physics, Unit 4, Quantum Physics, and Unit 5, Crystal Physics. In our first session, we are going to discuss about the unit number 1, Properties of Matter. Let me enter into the session. In this session, we are going to discuss about elastic and inelastic body. What is meant by stress, strain, and what are the relation between stress and strain with the help of Hooke's law, and the types of modeling, and the relation between stress, strain with the help of diagram. What are the factors affecting elasticity, and determine the rigidity modulus and moment of inertia with the help of torsional pendulum. What is meant by elasticity? What is the necessity? You know, the properties of matter, that is the properties of materials. The materials are classified into 3. You know, in the lower classes, there are 3 types of materials. One is a solid, liquid, and gases. That is well known about these things in the lower classes. Among the 3, we take the first one, solid. Solids are having a definite volume and shape. What is the reason for that? The solids are made up of atoms. Each and every atoms having some force between the neighboring atoms. That is an interatomic forces. That means due to the interatomic forces, each and every atoms are bound together. You know, yes, that is a binding force between the 2 atoms. What is the reason for that? What is the role of this binding force in the elasticity? Now, we have to take one elastic material. Now, we are going to apply an external force. That means, due to the application of force, the shape of the body may change. There are 2 types of force are there. One is an compressive force, another one is an elongation force. Whatever it may be, by application of force, the shape of the body changes. The name of the force is known as deforming force. Due to the application of external force, what will happen inside the body? Due to the application of compressive force, the interatomic distance between the 2 atoms will be decreased due to the compressive force. We are given elongation force. What will happen? The distance between the atoms between the 2 due to the forces will be elongated. There are 2 types of forces. Based on this, we are going to explain the elastic behavior of the material. Okay, go to the next one. What is meant by elasticity? Now, we have to consider one material or body. Now, we have to apply an external force. The body will deform. After removal of the force, the body regains its original shape. That materials are known as elastic material. That property is known as elasticity. That property is known as elasticity. So, once again, we have to apply an external force. Due to the application of external force, it may be a compressive or elongation force. The body will be deformed. After removal of the force, the body regains its original shape. That kind of materials or bodies are known as elastic material, and this property is known as elasticity. So, now we are clear about what are elasticity, what are all known as elastic bodies. Okay, so once again, the body which gains original shape and size when the deforming force is removed is called elastic body. Okay, These are all some examples for elastic body. The bone form, day-to-day life used rubber band, saucer ball. These are all examples for elastic body. Okay. What are the another kind of body? That is an inelastic body. That is another kind of the body. That is an inelastic body. The property is ultimately that is an ulta of the elastic body. That is what should be inelastic body. The inelastic body is one. We have to apply an external force. After removal of the force, the body doesn't get to the original shape. That means the inelastic body is one that does not return to its original shape. That kind of bodies or materials are known as inelastic body. These are all some of the examples. Clay, inelastic balls, that is bread and onion, solid rigid materials are known as inelastic body. Okay. Based on the material, we are classifying materials into two. One is an elastic, another one is an inelastic. Okay. These elastic and inelastic properties are explained on the basis of some of the important physical parameters that are known as stress and another one is strain. What is meant by stress? What is meant by strain? Okay. The stress is nothing but generally called as cause of deformation, and the strain refers to the effect of deformation. That means once again we have to take one elastic body, we have to apply a force. The body becomes deformed. When we apply a force, that is application of force is known as the body becomes stressed. So due to the stress, the body causes deformation. Due to the application of stress, the body becomes strained. That is known as effect of deformation. So depending upon the stress, the strain will be produced in the body. So stress and the strains are interdependent. So we have to apply stress to the body. Due to the application of stress, the body will be changes as already told. What is the strain caused? That is the effect produced due to the strain. We will discuss later. What is meant by stress? What is the definition for stress? The stress is defined as the ratio of an applied force F to the area A over which it acts. That means the stress is defined as the ratio of applied force to the area. Therefore, stress is equal to force by area. It is notated as F by A. The force is the applied force. It may be a compressive force or elongation force. That is notated as F. And the over which the area the force is acted, that is an A. Therefore, stress is equal to force by area. The unit of stress is Newton per meter square. Newton for force and meter square for area. This is the simple definition for stress. What is meant by strain? Due to the application of strain, the shape of the body, the dimension of the body will change. That means the strain is the ratio between change in dimension to the original dimensions. That means the relative change in the dimensions of the shape of the body as a result of applied stress. Therefore, strain is equal to change in dimension to the original dimension. This is a simple explanation for strain. Strain has no unit because both the numerator and denominator are dimension representation. Both the units are cancelled. So strain has no units. Now we have a simple idea about what is meant by elastic body, what is meant by inelastic body, what is meant by stress, what is meant by strain. Now we are going to relation between stress and strain with the help of Hooke's law. What is meant by Hooke's law? Within the elastic limit, the stress is directly proportional to strain. So again, within the elastic limit, the stress is directly proportional to strain. Stress directly proportional to strain is mentioned here. This is the proportionality symbol. Usually, here we have to note one point. This is the condition for Hooke's law. That means within the elastic limit, the stress is directly proportional to strain. The Hooke's law obey only within the elastic limit. It will cross the elastic limit, it doesn't obey. So within the elastic limit is an important condition for Hooke's law. Within the elastic limit, the stress is directly proportional to strain. Here we have to replace the proportionality symbol for equal. Therefore, whenever the proportionality symbol replaced by equal, you put a constant K. Therefore, stress is equal to K into strain. Here K is the generally called as a proportionality symbol or proportionality constant, where K is known as modulus of elasticity. That is an important term, where K is known as modulus of elasticity. There are three types of modulus of elasticity. One is a Young's modulus, bulk modulus, another one is a rigidity modulus. Once again, here the modulus of elasticity is extracted from the constant proportional to constant K. There are three types of modulus of elasticity. One is a Young's modulus, another one is a bulk modulus, another one is a rigidity modulus. In our chapter, we are going to discuss about the two modulus only. One is a Young's modulus, another one is a rigidity modulus. So one by one we are going to discuss. Now, before going to the modulus of elasticity, we have to draw a diagram. Now we are going to relate the stress and strain with the help of diagram. For that, this is a simple diagram for relating the stress and strain. For drawing the diagram, first of all, we have to fix one wire, that is an elastic wire or inelastic wire. We have to fix on one wire which is rigidly fixed at one end and gradually lowered at the other. That means, the wire contains two ends. One end is rigidly fixed and the other end is we have to apply the load. Due to the application of the load, varying load, the stress proportional to strain will be changes. Based on this, we have to draw a graph. Okay, yes, what will changes when we apply stress the corresponding strain in this graph? Okay, yes, listen to this graph. You have to consider the strain along x-axis and the stress along y-axis. The strain along x-axis and the stress along y-axis. Here, the graph is drawn like this. Just listen. First of all, starting the graph with O and then move to A dash, B, C until end is D. There are different points are mentioned in the graph. One by one, we are going to discuss what are the points mentioned. First one, elastic range. Elastic range. The elastic range is represented here. That is the range up to from A, that is starting from O and up to A. The OA portion represents the elastic range. This is the elastic range is a simple, just listen, this is a simple straight line. Simple straight line means whenever we are going to draw a graph always, it is in straight line. The x-axis term and y-axis terms both are directly proportional. That means up to A, that means from O to A, the graph becomes straight line. The stress is directly proportional to strain. That means that it obeys Hooke's law. The region from O to A, the stress is directly proportional to strain. Then only we get a straight line. Therefore, stress is directly proportional to strain. The range is known as elastic range. That range is known as elastic range and also obey Hooke's law. Next we move on to another point A dash. Next we move on to another point A dash. This is nothing but when we increase the load in the free end, what will happen? Up to the maximum limit, it will reaches the point A, it is crashed. The strain increases rapidly than the stress. Up to A, the stress is directly proportional to strain. Once again, from O to A is known as elastic range that obeys Hooke's law. When we increase the load, it will reaches the point A dash. What does it mean? In the point A dash, when we small increase in stress, it will produce a little bit changes in strain. That is known as A dash. That is known as elastic limit. That is the boundary of the elastic point. After that is up to A dash, we have to increase in small stress. It will produce a major changes in stress. Major changes in strain. So that up to the point A dash, it reaches the elastic limit. When we apply a load after the A dash, some of the changes will be takes place. That means after the point A dash, we have to apply the load the 50%. That means the wire becomes partially elastic and partially plastic. That means this is A dash to B. A dash to B, when we apply a load, what will happen? The wire becomes partially elastic and partially plastic. Okay, this is very important point. The point B is known as yield point. The point B is known as yield point. Now we have to increase the stress. That means we have to add the load at the free end. What will happen? If a small external force is applied, the body will take a new path BC. That means we have to apply the further load. The graph will take a new path that is known as BC. That is, the body will take a new path. What is the mean? Now, before the region A dash to be 50% plastic and 50% elastic. After the given point B, the elastic property becomes simply vanishes and it will change it to fully plastic range. So this is known as from B to C. The range is known as plastic range. That is an important one. From once again from O to A, the stress is directly proportional to strain. That is an Obey's law. After the point A, we have to apply a small stress. The strain will be more changes. Further increase of load from A dash to B. The 50% of stress and 50% of strain. That means the 50% of the body becomes plastic and the 50% of the body becomes elastic. Once again we have to apply the stress on after that beam. It is completely change over to plastic. So it is called plastic range. That is very important. Now furthermore we have to increase the load after the point C. What will happen? The body will move it will not come to an original shape. It will be permanently fixed and it will move towards the breaking point. That is very important. The breaking point is D. That means what? We have to further increase the load. The wire becomes turnout. That means it will reach the breaking point. That is, this point is known as ultimate strength or tensile strength. Okay, so it is called after the point, the C, the point is known as ultimate strength or tensile strength. We have to apply a force or load on after the point C. What will happen? The wire becomes broken into 2 or more portions. That means it will move towards the breaking points. Okay, this is the simple diagram for explaining or relating the stress and strain. Once again, we will conclude the diagram, the stress strain diagram. The portions OA representing elastic behavior. That means stress is directly proportional to strain, and the A to A dash, that it will small produce a stress, more changes will be produced in the strain. A dash to B, 50% of plastic and 50% of elastic. After the point B, it will completely change over to plastic ring, that is a tensile strength. We have to increase the further more of load. What will happen? It will move towards the breaking points. That means after application of further load, it will break into 2 or more pieces. This is the relation between stress and strain with the help of the simple graphical representations. Next we move on to another one, that is these are some other points already discussed. Elastic range O to A, limit of proportionality the point A, elastic limit A dash, yield point B, the plastic range B to C, breaking point D. These are all already discussed. This is separately mentioned for your easy understanding. Okay. In our first session we have discussed elastic and inelastic body, stress, strain, and relation between stress and strain based on Hooke's law, and the different types of modulus of elasticity, and the relation between stress and strain with the help of the diagram. Now we are move on to session 2. We are going to discuss about some of the definitions and concepts based on the session 1. That are what are the factors affecting elasticity, and other one we have to determine the rigidity modulus and moment of inertia of a disc with the help of torsional pendulum. Now we move on to session 2. In this session we are going to discuss about what are the factors affecting elasticity, and another one is an important university based questions to determine the rigidity modulus and the moment of inertia on the basis of torsional pendulum. Let me move on to the first one, the factors affecting elasticity. Yes, here there are 5 factors are there to affect the elasticity behavior. The number 1, effect of stress. Number 2, effect of annealing. And the third one, effect of temperature. And fourth one, effect of impurities. And fifth one is an crystalline nature. Based on these things, the elastic behavior may change. Change means it may be increase or decrease. We will discuss one by one. First one, effect of stress. We know when a material is subjected to a large number of cycle of stresses, it loses its elastic property. That means we have to take one rubber band, we have to apply a compressive force or elongation force continuously to the rubber band. What will happen? After a several of cycles, the rubber band is cut into 2 or more pieces. This is the one example. So we have to apply a continuous cycle of stresses. The elastic material loses its elastic property. Next one is an effect of annealing. What is meant by annealing? Annealing is the process by which the material is subjected to a high temperature and then slowly cooled. This is the method of annealing. Once again, the annealing is the one of the method. We have to increase the material to a high temperature and cooling that material step by step. This is the method of annealing. In this method, what will happen to the elastic material? The material to increase the softness. That means wherever we want the elastic material to be high soft in nature, we have to use this effect of annealing methods. Okay. Third one, effect of temperature. This is general one. The elastic property of the material changes its temperature. The elasticity increases with the decrease in temperature. That means an inversely process. That means we have to increase the elasticity, the temperature of the material, elastic material to be decreased. That is an inverse process. That is the third one, effect of temperature. And the fourth one is an effect of impurities added. That is an foreign element to be added to the main one. The addition of impurities produces here variation in the elastic property of the material. That means to increase or decrease of the elasticity depending upon which type of material is to be added the original one. That means the increase or decrease of elasticity depending upon the impurity added to the main one. That is the effect of impurities. The last one is an crystalline nature. The elasticity also depends on the types of crystals. That means that we know there are 2 types of crystals. One is a single crystal, another one is a polycrystal. For a single crystal, the elasticity is more. For without adding polycrystal material, the elasticity is less. In this way, we have to classify what are the factors affecting the elasticity of the materials. Next one, the different types of stress, that is a torsional stress. Just listen here. This is a simple one animation video. This is a simple wire with a simple torsion. This is another one. This is another animation video. This is also under torsional actions. What is meant by torsion? That is nothing but the shear stress produced when we apply the twisting moment. We have to produce a twisting on the wire. What will happen? It will produce a shear stress. That is the main cause for torsional stress. Okay, this is to be clearly viewed in these 2 animated diagrams. This is nothing but torsional stress. Based on the torsional stress, we have to take one important pendulum. In the lower classes, we have discussed a simple pendulum. That is, pendulum means we have a to and fro actions. Here, the pendulum is oscillate on the basis of torsion produced in this thing. That is known as torsional pendulum. Just go through with the diagram. This is a simple fixed end. In another end, we have to fix a circular metal disc. This is a torsionally flexible elastic wire. This is a torsionally flexible elastic wire. This is the simple metal disc that is attached to the free end, and another end is a fixed end. Therefore, the torsion pendulum is a simple oscillator for which the restoring force is nothing but a torsion. The torsion is produced due to restoring forces. Here, the device consists of a disc or a body with other free end and another end is a fixed one. This is the simple diagram of torsional pendulum. Okay. Based on the torsional pendulum, we are moving on to one important university based questions on the basis of revised Bloom's taxonomy, that is an object oriented learning formats. Okay. Here our main topic is a torsional pendulum. Course objective, what is the main objective of this questions? To understand the rigidity modulus of the wire using torsional pendulum. This is the main objective. There is a course objective to understand the rigidity modulus of the wire using torsional pendulum. This is the another general objective. Based on this, what the topics we are going to discuss? To study the moment of inertia of the torsional pendulum and the rigidity models of the wire. Already we have seen the diagram. That is, the disc is attached to the wire. Based on the setup, we are going to study the moment of inertia of the torsional pendulum and the rigidity models of the wire. This is our general objective. Okay. Based on this, some of the specific objectives of this topic. First one, that is an define whatever we are going to discuss these things. These are some of the questions. After completed the topic, these questions may be arised. Define rigidity modulus. How to determine the rigidity modulus of the wire? What are the methods are there? Third one is an determine the moment of inertia of the torsional pendulum. And the fourth one is an extend the idea to find the moment of inertia for regular and irregular body. That means we have to extend the idea of the third one to fourth one to extend the ideas to find the moment of inertia of a regular and irregular body. Okay, let me move on to the next one. This is a simple comparison diagram for knowledge dimension with the cognitive process. This is what simple weightage to the each and every questions. These are the general sketches. What are the types of sketches? Equation we have to study. We have to go through in this topic. That is simple sketches of simple. That is a simple diagram of torsional pendulum. These are some of the equations we are going to derive based on the complete derivations. Okay. First one is we are going to derive the period of oscillation of torsion pendulum, that is T is equal to 2 pi to root of I by C, and another one is rigidity modulus of the suspension wire. N is equal to 8 pi IL divided by R power 4 T square. Based on this, we have to calculate the moment of inertia of the disc. I naught is equal to 2m d2 square minus d1 square into t naught square divided by t2 square minus t1 square. Based on this, some of the similarity questions are also discussed. Define what is by torsional stress, what is Poisson ratio. These are all some related topic related to the content. Okay, what is meant by torsional stress? That is already discussed. When a body is fixed at one end and twisted about an axis with the help of torque at the other end, then the body is said to be under torsion. That is already we have a simple animated diagram already go through. Next one is on Poisson's ratio. It is defined as the ratio between lateral strain produced due to the longitudinal strain within the elastic limit. Okay, this is the simple Poisson's ratio. Therefore, Poisson ratio is nothing but ratio of beta to alpha. That is lateral strain to longitudinal strain. This is, and the other one is a mind map. That is your activity. After complete topic, have to design your own idea as a mind map. Okay. Let me move on to that topic. That is a simple concept map. What we are going to do is a simple pictorial diagram. This is elasticity of the main topic. Based on this, what is going to be already discussed. There are three types of modulus. We know Young's modulus, rigidity modulus, and bulk modulus. The rigidity modulus is used to determine the torsional pendulum. With the help of torsional pendulum, we have to calculate. We have to determine the rigidity modulus of the wire and the moment of inertia of the disc. Okay, this is a simple flow diagram for your easy understanding. Let me enter into the questions. This is the session objective. At the completion of this session, the students will be able to understand the basic ideas about rigidity modulus of the wire and the moment of inertia. This is the main objective. First one is a rigidity modulus of the wire and the moment of inertia of the disc on the basis of torsional pendulum. This is the main questions. We are going to determine the two things. One is a rigidity modulus and the moment of inertia with the help of torsional pendulum. This is the simple experimental setup. This is the experimental setup. There is a retort stand. This is a fixed end. In the other free end, we have to fix one circular metal disc. Here we have to produce a torsional rotations. If this is the simple setup, a body suspended by a thread or wire which twists first in one direction and in the reverse direction. In the horizontal plane, it is called the torsional pendulum. That is already discussed. A simple schematic representation mentioned here. That is, this is the simple diagram of this our topic. Based on this, we have to calculate the period of oscillation of torsional pendulum. The period of oscillation, you know, the period of oscillation is time taken for one rotation or one oscillations. That is a period. Therefore, the period of oscillation of the torsional pendulum T is equal to 2 pi into root of I by C, where I is the moment of inertia of the disc and C is the couple per unit twist that is produced in the twisting wire. Therefore, the period of oscillation T is equal to 2 pi into root of I by C. This is our equation number 1. But we have an expression for couple per, this is a predefined expressions. Couple per unit test C is equal to 1 by 2 pi n r power 4 divided by L. This is equation number 2. Here L is the length of the suspension wire and R is the radius of the wire. Here N is our requirement and it's a rigidity modulus of the suspension wire. Now we are going to substitute the equation number 2 in 1. What will happen? Substituting equation 2, we get a rigidity modulus of the suspension wire, that is N is equal to 8 pi IL divided by R power 4 into T square. This is, we have treated as equation number A. Here I is the radius of gyration, I is equal to 1 by 2 m R squares. Okay. Now we have to introduce some of the important parameters, the important quotations of these equations. Let the I0 be the moment of inertia of the disk and the I1, I2 be the, they mentioned here I1, I2 be the moment of inertia of the disk with the identical masses at a distance of d1 and d2 respectively. And I power 1 is the moment of inertia of each identical mass about the vertical axis passes through the center of gravity. Once again, I0 is the moment of inertia of the disk and I1, I2 be the moment of inertia of the identical masses placed at a distance d1 and d2, and the I power 1 is the moment of inertia of the each identical masses. Therefore, based on the pattern axis theorem, we may write I1 is equal to I0 into I power 1 plus 2m d1 square. Similarly, I2 I0 plus 2I1 2m d2 square, and based on the equation 3 and 4, that means I2 minus I1 is equal to 2m into d2 square minus d1 square. Once again, this is equation number 3, this is equation number 4. 3 minus 4 gives the equation number 5. When you know from the equation 1, go to the previous slide, this is the equation number 1. We may write squaring on both sides. T0 square is equal to 4 pi square I0 by C. T0 square is equal to 4 pi square into I0 divided by C. This is equation number 2. Similarly for T1 square, 4 pi square I1 by C. Equation number 7. T2 square is equal to 4 pi square I2 by C. Equation number 8. On basis of the equation 6, 7, 8, that means T2 square minus T1 square, that is equation number 8 minus 7 is equal to 4 pi square by C I2 minus I1. Here T1, T0, T1, T2 are the period of torsional oscillation about the identical masses with the position of the identical disk masses D1, D2 respectively. Here once again T0, generally T is represented for period of oscillation. Here T0, T1, T2 are the period of torsional oscillation without identical masses with the position D1 and D2 respectively. Therefore, from the previous equations, equation 6, 9 and 5, dividing equation 6 by 9. Here, this is equation number 6, this is equation number 9, this is equation number 5. Based on the three equations, dividing equation 6 by 9 and using 5, we get an equations T0 square divided by T2 square minus T1 square is equal to I0 divided by I2 minus I1, I0 divided by 2m into D2 minus D2 square minus D1 square. This is represented as equation number 10. Therefore, from this we have to calculate the moment of, this is our main requirement, we have to find the moment of inertia of the disk is equal to, here I0 is the I0 is equal to 2m into D2 square minus D1 square into T0 square divided by T2 square minus D1 square. This is our one of the required determinations, that is equation number 11. Now, our another requirement is an rigidity modulus for wire. That means the moment of inertia of the disk that is discussed. Based on this, we have to calculate the rigidity modulus of the wire. For that, substituting equation 11 in equation A, substituting equation 11 in equation A, we get the rigidity modulus directly. Eta is equal to, or N is equal to 8 pi L divided by T square R power 4 into 2m into D2 square minus D1 square into T2 square divided by T2 square minus D1 square. This is simple mathematical substitution. Or N or eta is equal to mathematical simplification 16 pi ml D2 square minus D1 square divided by R power 4 T2 square minus D1 square. This is our two main determination. Moment of inertia of the disk. Another one is an rigidity modulus of the wire. This is frequently asked university questions. Okay. Based on this session 1 and session 2, we have prepared some of the objective type questions for your reference and for your recalling the ideas. First one is when too many people stand on a bridge, it collapses. What is the reason? Actual answer is due to increase in stress. Another one is due to overweight, due to improper construction, due to friction. First one is the answer. What is the reason behind that? Students have to submit the reason as the assignments. Okay. Question number 2. For a constant force, a rope breaks due to stress. Which are the following useful to reduce the stress? The answer is increase the cross-sectional area of the rope. Just go through the previous concept and write the reason for these questions. Question number 3. When a rope is pulled on either side, what is the stress acting on it? The answer is tensile stress. And fourth one is fluids cannot resist shear stress. It is true or false? By the answer, it is true. What is the reason? What happens when the stress applied to the body is increased beyond the maximum value and is removed after some time? What is the reason? Body cannot return to its original positions. This is already discussed, and also you have write your answer as in assignments. Okay. Thank you for this session. Thank you.